All right, so we're going to talk a little bit about metric system, and I am going to leave it like this instead of going in present mode because I'm not convinced it will record everything. So just to kind of go over what's a standard of measure, we're going to attempt to That gave you a little background history about why we have the metric system now and the importance of a sort of a standard. So just some things to pull out is it's based on a natural constant, not like somebody's hand or width of, or length of foot. And it's made to make measurements and calculations easy. It's base 10, it's decimal. You don't have to worry about fractions. You've got prefixes that allow you to that tells you what's small and what's large measurement, and there are fewer units. So the main ones we'll deal with are meter, gram, and liter. And this allows scientists in other countries to compare notes, understand each other, and to keep from wasting time converting because that decreases how accurate it is. That is why that rover or satellite crashed into Mars, is because they converted instead of using the same standard of measure. So we talk about accuracy and precision. So you want to make sure you understand the difference. Accuracy is how correct the measurement is. All right. So when I grade something, we're grading for accuracy. Is your answer correct or not? So your grade is like an accuracy, is based on accuracy. Precision is how specific the measurement is or how consistent multiple measures are. So this little chart kind of helps you see the difference. If it's precise and accurate, you hit the bullseye every time in the exact same spot, even though these aren't, they're off just a little bit so you can tell there's multiple dots there. Um, if you are precise but not accurate, you're hitting the same spot, but it's not the bullseye. Accurate would be the bullseye, but it's precise because you're hitting the same spot. This is accurate because you're getting the bullseye. It's not precise because you're not hitting the same exact point every time. Here is neither because none of them are in the same ring. None of them are on the same spot. And so this is why we need a standard. We need that accuracy and precision. Okay, so accurate means it's in sort of the same area. Precise is it's the exact same thing every time. So if every time you take a quiz, you get a 88 on it every time, regardless of what the topic is, that's precision. Accuracy would be making 100 every time. Am I doing that right? I think with that. So that's sort of the difference there. So here's another example. If a student knows 85% of the material for the test but makes a 70% on the test, is it accurate, precise, or neither? Well, it isn't precise or accurate. If he knows 85%, then he should have made 85% on it. Okay? So they would be the same if it was precise, and accurate again to me would be, 100%. So that's just some examples. You can go back and look at the PowerPoint when I post it. So a standard is an exact quantity that people use for comparison. And so this is what the SI system or the metric system does. And so it uses prefixes, multiples of 10, and they all have a base unit. So we're going to quickly look at that. You need to know that for length, it's the meter. We abbreviate it with a lowercase m. Mass is kilogram, and it's kg. This is not weight. Weight is a force. This is mass. So it is usually measured with a digital scale. Volume, we're going to use the liter, and the L is always capitalized. So if it's milliliters, it's lowercase m, capital L. And reading a graduated cylinder, water, due to its properties, curves because it's attracted to each other and the sides of the glass here. You have to read it at the bottom of the curve. The water will curve up here, And the bottom, this curve is called a meniscus, and you read it at the bottom. That's why you're supposed to get and look at it eye level. Set it on the table and bend down and look eye level. Time is seconds, is the main unit or base unit. And then, temperature is actually Kelvin, but we do not measure Kelvin in what we do. We use Celsius. So Kelvin is what scientists may use, but Celsius is what is available sort of for the average person. We in the United States, we're used to Fahrenheit, but in science, we use Celsius. We're not going to learn conversions between those. Um, Here are the prefixes. Now, in one of the videos you're going to watch, you're going to see a different little saying than this. This is one of the sayings. King Henry died unusually drinking chocolate milk. It lets you know what the prefixes are. K is for kilo, H is for hecto, D is for deca. Sometimes they will, deca is DK or DA. U is for your base unit. That's your liter, your gram, your meter. C is for, this D is for deci, and it's just a lowercase d by itself. Deca usually has a K or an A with it. C is for centi. M is for milli. If you're DCM, that means it's a decimal. If you're above the U, it's a whole number. Okay, we're going to use this for learning to convert for something we're going to do tomorrow. So, for example, if you know this saying, you can write out what's in blue here on your paper. And if I were going to convert from this, I would start with what I'm given. If the symbol is by itself, it is a base unit. So M is meters. I'm going to start at the U because that's where the M is going to be. Then, I thought I could get right with this. Yes. So I would start right here. All right. Then I want to go to kilometers. Kilometers is K. That means I want to go to king right here. So to do that, how are you going to get there? Are you going to move right or left? I'm going to move to the left, and I'm going to jump. Jumping from U to D, jumping from D to H, jumping from here to K. Is it time for him?
Yeah, they're a little early today. But
okay.
I told them to let me know if it needed to be earlier than 12:45.
All right. This video will be on Cameron, and then just the two Ed Puzzle videos. So I've got, how many jumps did I make? I went from 1, 2, 3. Notice I did an arrow to the left. So if I were to do this, I would start here because this is where the decimal is, even though you don't see it. 1 jump, 2 jumps, 3 jumps. This is where my new decimal is going to go. These empty places, I have to have a 0 there. So if I look down here, my answer is decimal 002. So you're going to have some practice tomorrow after you've watched some videos with that. Now let's see if that stays or moves, or what does it do? How do I get rid of it now? Or am I at the end? All right, I am here. All right, so we're going to practice this. So remember, I have King, this is hard, Henry died unusually drinking chocolate milk. I have to be careful not to hit those buttons over there. All right, so I'm starting with this M here. It's not by itself, so I know I'm starting here. So that's milligrams. This letter is by itself. That means I'm going to the U because G, M, and L are the U. So I'm going to jump 1, 2, 3 places to the left. If you don't see the decimal, it's always here at the end. 1, 2, 3. It is just a 2. All right. So I don't know if I can change color or not. I think I can. Let's try blue. All right. So here I'm starting at K and then M. So I'm going to start here. M by itself is the middle. So this time I'm going 1, 2, 3 to the right. My decimal is considered right here. So 1, 2, 3, my new decimal. I have 3 empty spaces, so it's going to be 1, 0, 4, 0, 0, 0. If you want to put the decimal, you can. Okay? Here, you're going to start with the C. Let's see if I can get a even different color here. All right, so C, I'm going to start right here, and I'm going to go to the M, which is the U. That's 1, 2 places to the left. Here's my decimal, 1, 2, 4.8. All right, so you're going to watch 2 videos that talk about the metric system and one that talks about this way of converting. Tomorrow, you're going to practice this way of converting, okay?